All right, this would still be a no calculator problem. Find the exact values of the 6 trig functions of theta. So first find the missing side. The hypotenuse is what I'm missing. So it's the square root of 2 squared plus 3 squared, which is square root of 13. And then we write all this out. Sine of theta equals 2 over radical 13, which is actually 2 radical 13 over 13. Always rationalize our answers for the AP exam and for this quiz. Cosine is 3 over radical 13, which is 3 radical 13 over 13. Tangent theta is 2 over 3. I'm just using SOHCAHTOA, by the way, to figure these out. And then you need to know the reciprocals. So cosecant theta, if I take the reciprocal of this value, I get radical 13 over 2 without having to simplify anything. Secant of theta is radical 13 over 3. And cotangent theta is 3 over 2. If you have a triangle, like in the second problem, you have a triangle that you can use a similar triangle to get to the reduced answers right away, that's beneficial. So, excuse me, instead of saying that the sine of theta is 10 over 26, I would say that the sine of theta is 5 over 13. So what you're doing there is making this similar triangle where you say, okay, these two sides have a common factor of 2. So I'm going to come up with a similar triangle whose side lengths are half as large. And I'm not saying these triangles are equivalent, but the trig values of the angle that they both share, the angle is equivalent in this triangle, the other one, the trig values are the same. So instead of saying sine of theta is 10 over 26 and then reducing that to 5 over 13, if I just use the small triangle, which Pythagorean triples, it's a 5, 12, 13 triangle, then I can get right down to the final answers without having to simplify every time. Plus, also finding that third missing side is not as hard. It's more obvious that this is a triple, or I at least have smaller numbers to work with when I'm doing Pythagorean theorem. Sine of theta is 5 over 13. Cosine of theta is 12 over 13. Tangent of theta is 5 over 12. And then the reciprocals. Cosecant theta is 13 over 5. Secant theta is 13 over 12. And cotangent theta is 12 over 5. The other thing we can do, instead of having to find all 6 trig functions, we can find 5 because you're given 1. So the difference between these two problems is just instead of me giving you the triangle, now I'm giving you one of the trig values, and then you build the triangle based off of that. So because sine is opposite over hypotenuse, when I draw my triangle, I'm not real worried about scale. Wherever I put theta, I need to put 2 opposite of theta. I need to make sure 5 is the hypotenuse. And then Pythagorean theorem, this is like 2 squared plus x squared equals 5 squared. So this side is going to be the square root of 5 squared minus 2 squared, which is radical 21. So we already have sine. We're going to find cosine theta. Scooch this over so I have room. So cosine theta is equal to radical 21 over 5. Tangent theta is equal to 2 over radical 21, which we need to rationalize. So there's cosine, there's tangent. Cosecant theta is the reciprocal of sine, 5 over 2. Secant theta is the reciprocal of cosine. Now that's going to be 5 over radical 21. So make it 5 radical 21 over 21. And cotangent, go off the first version. Reciprocal of that is radical 21 over 2. If tangent of theta equals 4, think of that as 4 over 1, so that you can say 4 is opposite and 1 is adjacent. So again, not worried about scale. I just draw a right triangle. I put theta somewhere. Opposite of theta, I put 4. Adjacent to theta, I put 1. And I'm finding the hypotenuse, so that's the square root of 1 squared plus 4 squared, which is radical 17. And then I go from there. So sine theta is opposite over hypotenuse. It's going to be 4 over radical 17, so I'm just going to rationalize right away. Cosine of theta is 1 over radical 17. So instead of 1 over radical 17, I'm going to rationalize right away. Tangent of theta is equal to 4 over 1. Oh, that was already given to me, so I won't write it down. Cosecant theta. Now, maybe it would be helpful if I would have written down the non-simplified version. So this was 4 over radical 17, right? Sine of theta was 4 over radical 17. So when you flip that, it's radical 17 over 4. And secant theta, same idea. Cosine was 1 over radical 17. So when you flip that, you get radical 17. And cotangent theta, the reciprocal of 4 is 1 over 4. All right, so here are these. And our last set for this, secant theta, that's the reciprocal of cosine. So remember, that's hypotenuse over adjacent. So this is a little different. The hypotenuse is radical 15. The adjacent side is 3. And so we have to find this missing leg. So 3 squared plus x squared equals radical 15 squared. So this is going to be the square root of radical 15 squared is just 15. Minus 3 squared is 9. So that's radical 6. So just a little different, nothing too crazy here, but we have 2 radicals in our triangle. So we will need to simplify. When we want to do something like sine theta, I get radical 6 over radical 15. So use your radical rules here. We did a lot of this in algebra 2. If you have radical over radical, that's the same as radical 6 over 15. And the reason I would do that is because that shows me that I can simplify this fraction. If I divide by 3, top and bottom, I get the square root of 2 over 5. So I still need to rationalize, but now I don't have to do 6 times 15 and then simplify all that. So when I multiply by radical 5 over radical 5, I get radical 10 over 5. All right, and then the cosine of theta is 3 over radical 15, which is 3 radical 15 over 15. And the tangent of theta is radical 6 over 3. And then for the reciprocals, cosecant theta, I'm kind of out of room here, but I want to take the reciprocal of my final answer here. It's going to be 5 over radical 10, which is 5 radical 10 over 10, which then you have to simplify, radical 10 over 2. So lots of simplifying for sine and cosecant here since they had 2 radicals. Secant we already have, that was given in the problem. And cotangent theta is 3 over radical 6. That's going to be 3 radical 6 over 6. And then that simplifies to radical 6 over 2. I guess this triangle, we probably could have like somehow reduced by radical 3, but I think that's more effort than it's worth there. Okay, now these problems are word problems. So this is like our calculator part. Our calculator part has, I think, 4 right triangle trig problems on it. So 1, 2, 3. So kind of similar to this. Also look at the practice that we did yesterday. So for each problem, show the trig equation, solve with 3 decimal place accuracy. You should draw a picture, but I'm not really grading your picture. I'm checking the trig equation and your answer. So angle of depression from the top of a tower 300 feet away. Angle of depression from the top of a tower to a point 300 feet away from the base of a tower. Let's just get this all down here. Tower, there's a point on the ground 300 feet away. Angle of depression, which is always from the horizontal, is 63 degrees. Again, nothing's ever to scale when I draw it. Angles of depression should always translate to angles of elevation in your picture because these are alternate interior angles. Geometry tells us that they are equal. Find the height of the tower. Let's call that x. Because I have opposite and adjacent, I need to use tangent. Tangent of 63 degrees is equal to x over 300. Multiply by 300 to solve for x. When you plug this into your calculator, make sure your calculator's in degree mode. If it doesn't say degree up there, or if it doesn't show you, press mode. Make sure degrees is highlighted. If not, highlight it and press enter. And then carry on. So 300 times the tangent of 63. So this is about, split screen here. So x is approximately equal to 588.783. My label on x is feet because that's what the 300 was measured in. All right, next problem. The top row of the red seats behind home plate at the old Cincinnati Riverfront Stadium was 90 feet above the level of the playing field. I found this in an old textbook, so I was like, oh, this is the old stadium. So, okay, so here we are, sitting 90 feet above home plate in the top row. Oh, the playing field, I guess. The angle of depression to the base of left field was 14 degrees. So I guess left field ought to be over to the left. This angle is 14 degrees. And I'm going to put that down as an angle of elevation right away. How far was the base of left field wall from a point on level ground directly below the top row? That's a very wordy way of asking, find this horizontal leg. So again, we're dealing with opposite and adjacent. So again, we're going to look at tangent of 14 degrees is equal to 90 over x. Now this time to solve for x, you would multiply x over, which means then to isolate x, you're going to divide by tangent of 14. So 90 divided by tangent of 14 degrees. So 360.970. And we were given feet as one of our labels, so this is feet as well. Right. The angle of elevation from an observer to the bottom edge of the Delaware River drawbridge observation deck, located 200 feet from the observer, is 30 degrees. This picture is given to us. So here, they marked in 200 feet. Here's a right angle. It's 30 degrees. The angle of elevation from the observer to the top of the deck is 40 degrees. What is the height of the observation deck? So figure out this height right here. So let's call that y. And we don't know the big dimension x. Actually, let me check to see. I want to keep my variables the same. This is what I did on my key. Okay, I flipped those. So sorry. Just to keep things consistent, I'm going to call the short distance x and the big distance y. And just because this is showing up kind of weird, I'm going to redraw it over here. So the smaller triangle to the bottom of the observation deck is has a 30-degree angle here. We don't know this distance, and we know this is 200. So tangent of 30 degrees equals x over 200. So 200 times the tangent of 30 is equal to x. And I'm not going to type that in yet because I want to figure out my other dimension. So the larger triangle, the top of that building, has, I'm calling that vertical distance y, still 200 feet away. And this angle is now 40 degrees instead of 30. So I'm still setting up a tangent equation. Tangent of 40 degrees equals y over 200. And the question was, what is the height of the observation deck? So if we're looking at the height of the observation deck, I think what they mean there is, well, actually, let's see. So I subtracted to find this distance. I'm not sure if that's actually, now that I read that again, what's the height of the observation deck? That's kind of weird. It seems like, what is this height? I think what they meant, checking the answer in the book on this, they meant like, they wanted us to find this. What is this little distance here? So I'm going to find y minus x. reading the wording of that again, I think it's kind of strange. But y minus x, well, y is 200 times the tangent of 40. So I'm just going to plug these into my calculator. So careful to do it in the correct order here. Y is 200 times the tangent of 40, and subtract x, 200 times the tangent of 30. So I know the wording is strange on this, but they would have no reason. If they just wanted us to find x, like the height of the bottom of that tower, there'd be absolutely no reason to give us this other section. So they wanted that difference. All right, so the difference is 52.350. And again, we're talking about feet for most of these problems. All right. Our last problem here, ignore that. Our last problem says, in traveling across flat land, you notice a mountain directly in front of you. Good observation skills. Its angle of elevation to the peak is 3.5 degrees, so this picture is already given to us. You drive 13 miles closer. Now the angle of elevation is 9 degrees. Approximate the height. Let's drop that in. Height of the mountain, let's call that y. And again, I want to keep my letters the same. Yes. Okay. So let's call that y. And then the other distance that we don't know that we'll need in the smaller right triangle, let's just call that x. So in the small triangle, we have the tangent of 9 degrees is equal to y over x. And in the large triangle right here, this horizontal leg, the adjacent leg, is x plus 13. So I'm going to say tangent of 3.5 degrees equals y over x plus 13. Multiply the denominators to the other side. Now, both of these equations are equal to y. So you could set them equal to each other right now and figure out what x is. But remember, you're not trying to find x, you're trying to find y. So if you do happen to find x, let's say you find x is approximately whatever, you need to take that answer, and according to this, y is equal to x times tangent of 9. So you need to make sure that you do x, your answer for x, times tangent of 9. I don't like to do that because sometimes on a quiz, especially, or a test, I might forget to go back and find y. Like I might do all the hard stuff and then I just forgot the last step. So if I'm trying to solve for y, I prefer to keep y in my equation. So that's why you'll see in this answer key and in the previous answer key with all the word problems, I like to solve these equations for y. I like to solve them for x, keeping y as the variable. So I can divide by the tangent in each equation. And then for this equation, I can take it further and subtract 13. And then because both of these equations are equal to x, I can set them equal to each other like I would have done before. And so now I'm just going to get right down to solving for y. The general steps are the same no matter what you do. You're going to set two equations equal to each other. You're going to get the variables on one side. So in this case, I'm going to subtract the y over tangent of 3.5. Subtract that to the left side. It's equal to negative 13. And then I need to factor out the y. So I would be doing all of these steps if I would have back here set the two y equations equal to each other. So I factored out a y. And then y is equal to negative 13 divided by the parentheses. You do need to correctly plug this into your calculator. So the reason I still am writing these parentheses is because that's how I have to type this in. So let me split screen here. All right, so I want to type this in. So negative 13 divided by parentheses 1 over tangent of 9 degrees. So I don't need parentheses around the whole fraction. The calculator does the proper order of operations down here. So it does 1 divided by tangent of 9, and then we want it to subtract 1 over tangent of 3.5. So I close my angle and I close the denominator parentheses. And so this is my answer for y, 1.295. And let's look at what that's measured in. I believe it's miles. Yeah, this was 13 miles. So this one is miles, height of a mountain. I guess that makes sense. And again, like I said, if you would have found x is not 1.295, but if you find x, multiply that answer by tangent of 9, and you should get the exact same thing. All right, that's it for this review. On the quiz tomorrow, I don't have any new types of word problems. So if you want to go back and practice what we did on Monday and what we did in the review, you're going to have to do something like this, where you have substitution, but you'll also just have to do basic stuff where you have maybe, an angle and a couple sides and you do one trig function. So just practice. And if you're good with your review and you're good with the problems from Monday, then you should be in pretty good shape for the word problem stuff. I do have office hours tomorrow, so stop in if you want more practice or if you have questions.